who here knows who Provable Things are? Anyone know who's heard of Oraclize? So we are Oraclize, or we used to be Oraclize, we're now Provable Things, but it's still the same. And we're here to show you how to develop data-rich smart contracts on Ethereum via Provable Things. So, who's hacking, presumably most of you? Who needs like external data for this smart contract? Yeah, you've come to the right place. Yeah. Because that is what we do. I'm going to read it out, and you can all read it as well. But we are a security-oriented data transport layer for decentralized applications to connect with web APIs, which is the same thing. We're a reliable bridge between smart contracts and the internet. That is a cool diagram to describe pretty much exactly that. And the technologies we use are obviously blockchain and trusted computing. You can see our repo at the bottom there. If you want to have a glance, there's tons on there. Probably better are the examples, but we'll get to those in a bit. So, some stats about us. I'm going to go quite quick so we can get to the code, because that's the bits that you'll care about, and that's the cool bit that's done. But we've been live on the mainnet since 2015, so that was back when we were called Oraclize. We have been here for a while doing our thing. We've done over 1 million I mean, that's actually old. We've done way more than that now. Probably 2, once we get near 2 million now on the mainnet. We've been adopted by thousands of projects and are available currently on 5 different blockchains. We are blockchain agnostic in terms of the service. We try and work on all sorts of places. Basically anywhere where there is demand for us, we go. So if you are working on a different blockchain and you need an Oracle service, send us an email and we'll say, hey, let's see if we can deploy on it. We are in books as well. If you haven't read this book, you should. We're in it, but that's not why you should read it. It's also brilliant. So yeah, we've been in the space. We know a few things. We use a single API to allow your contract to use external data, and this is pretty much all you need to know in order to use us. So obviously, there's a very important ellipsis there, which is hiding a little bit of stuff, but not much. So other than the ellipsis, this is all you need. You need our API, which if you're using Remix, who uses Remix here? Sweet. Anyone using Truffle? Good. We've got you all covered. We're on both. I prefer Truffle. Sorry for having never in there. Only because it's command line, and I'm a command line fan. This laptop's making noises, but I've been lent it. It just wondered. I wouldn't have a clue how. I've never used it. This is my tech support. It's very, very awesome. Thank you so much. So, oh yeah, here we go. So that bottom line, import github.com/oraclize, oops, that should say Provable Things. I should have paid more attention. The API bit is correct, but it should be /provable-things, Ethereum API, Provable API.salt. With that imported into the topic of contract, you will get access to our entire API, whose methods you can use to call any URL you like via the construction, which is a bit higher up, where it says provable_query. So first we inherit it using provable, and then we can call that query to make our code. It is that simple. As I've already spoiled ahead of time, we are on all sorts of different development environments. We've got the Zeppelin kit that they are running there, creating a cool new OS. With Truffle, with Remix, with a plugin there. We try and get everywhere because, like most of these places, like the developers who are important, and we need to make it as easy as possible for us. I was going to say you guys, but I'm a developer too, so we need this stuff to be easy so that we can actually build cool things instead of being mired down in lots of docs and difficult. So that's what we go for. So I'm going to show you this, which is our simple way of using it with Truffle. So I haven't got an example showing you with Remix, but it is as easy as copy and pasting code in. In fact, in our examples repo, any of those examples can be dropped straight into Remix, just copy and pasted, and you can go straight from there. So it's that easy. With Truffle, for the and we provide the Truffle box, which is a great way to get familiar with the service. If you just have a look at that thing there, who's used Truffle boxes before? Yeah, they're super easy, right? It's just an unpack and it does everything for you. So our Truffle box does all those same things for you. You pull it down as a smart contract. That's an example. It pulls down our API. It has everything imported. and more importantly, it includes one extra special bit, which is this bit. I'll go back to the one in a minute. And the extra special bit is what we call the Ethereum bridge. And the reason this is extra special is this means that you can leverage our service on any blockchain of your choosing, whether it's private or not. So when you're developing in Truffle, you're going to be using the Truffle framework, and you want to spin up a local chain. You don't want to have to keep using Ring2 or whatever. You want to use a local Ganache chain via Truffle, so everything's intermined, which means you can iterate over your tests faster. And you should be testing all the time, especially when it comes to immutable smart contracts. So the Ethereum bridge allows that to happen, so you can use our service in your completely local dev environment and still get the same provable Oracle service, which is great. I would say that, but I actually think it. If you want to have a look at the Truffle box, it is as simple as that. This is the only slide I have on it, so if you wanted to do it, feel free. But it's going to be on your own after these 3 commands, but it's to show you how simple it is to get going with this stuff.
In the documentation for the hackathon, the Open Zeppelin provable starter kit extension, how did the Truffle box and that compare?
Okay, let me think and hark my mind back to the Zep. Oh yeah, so the Zep kit has actually got a full front-end DApp on it as well.
Okay.
So it's, I think it's a different example, but the actual back-end, i.e. the smart contract, is exactly the same as any of our provable ones. It uses the exact same API, the exact same query style. It just has a front end bolted on. So if you're interested in developing a smart contract specifically and you're just going to do any old front end to be quick and easy, it's probably quick to go with Trufflebox. If you want a more polished DApp, but it's probably a bit harder for you to hack into because it's a bit more finished, you can use the Zepkit. But that's the main difference.
Thanks.
I don't have any slides on the Zepkit though, sorry Zepkit. It's really cool. So when you've downloaded the Trufflebox, you can just run the test like this. The reason we've set it so that you can run tests straight away is because if you do that, you get to see that it is making a provable query whilst you watch it, and that's in your local Ganache chain that it spins up for the tests, and it's super fast, and it just shows you how quickly you can start iterating over your smart contract, even when they include external data. So it's super cool. Now, this is the important bit. This is what you care about. So this is why I've raced through the things. So any questions first before I show some stuff? No? Cool. Sweet. Let's see it. Right. This is a complete smart contract that works and is using our API in order to get external data. So you can, I'm going to make this available on the Discord channel somehow at some point. But you can just copy and paste it straight to Remix or into a and it's a very important contract because as you can see, we're actually trying to find out the temperature here at ETHBoston. So granted, you can just go outside, but we prefer to do it this way because it's a hackathon after all. So what you are looking at here is the basic framework of making a provable query. And you can see right at the top, you have an import statement, which is the API. Once that's imported, all you need to do is inherit it, which is what's happening on the contract. Temperature at ETHBoston, it's using provable. We called it using provable because it reads way nicer. That's the only reason. And then you have a bunch of stuff, the storage instability, the jacket required, which is an important pooling, the temperature at ETHBoston, which is what we don't know yet, but we soon will, and the temperature under which a jacket is required, which I have put 18 because I am from the UK, and that is 18 degrees. I have no idea what it is in Fahrenheit. It's probably really cold, but 18 degrees is my temperature. More importantly, in order to use the API, you need to make a provable query, which if you look at the function get temperature, you can see it says provable query. And it is as simple as passing in 2 parameters. In this case, the first one is URL capitalized, and that is what we are calling the data source. We're saying, hey, provable, please make me a URL query. And the next parameter is, unsurprisingly, the URL that you want. Alright, ignore the JSON wrapping around it for 1 second. All you can see is we've got a generic URL to a weather API at glitch.me with a latitude and longitude that I put in that happen to coincide with where we're sat right now. You would have thought it. And with those two bits of info, i.e. a URL and a request for a URL, we have our provable query. Now, the JSON bit around it simply is an extra bit you don't have to do, but is a useful tool where it allows you to parse the response from a URL, because if you're going to call random URL APIs, you might get giant responses. And the way they are returned to your contract is via a string, and if it's giant, it won't fit. You can't get one in a block in a single transaction. So if it's a JSON, we can actually parse down to the bits we want so that what you get in your contract is only what you're after. So this is what the JSON brackets and then .main.temp is just saying, hey, I want to read JSON and I want the main value and temperature main. Done. So once you have that function set up, you have a provable query ready to go. What it needs is a callback. Our standard way of doing the callback is by the double underscore. And the callback takes two parameters, can't read, in this case. And they are the query ID and a string which will be the result. So this callback function is actually what the provable service calls, which is why the next line has a requirement on it to check whether the message sender calling this function is indeed a provable address, because you don't want this to be called by anybody. Otherwise, anyone can send whatever data they like to your contract. You want us to send you the data that you've requested provably, and that's what the requirement does. At that point, we're going to actually look at our result, which here I've actually just passed it as an int. It's actually a uint, so that's a badly named. But the parse int, if any of you are familiar with Solidity, is not a Solidity function. It is one of the helper functions we provide in the API. So when you inherited it at the top, it comes with a whole bunch of helper functions which don't get compiled unless you actually call them in your contract, so it's nice and light. In this case, it will compile the parsing function because we used it. And where you're setting a boolean to whether the temperature under which jacket required is greater than or equal to the actual temperature that is the result. And finally, we actually just log the result so people can see it when you run this code. So I would, if I could, have shown you this on Remix, but what I'm going to do is trust that you all can click buttons the same as I can, and you can just copy and paste it into Remix and run it straight away. The point being, this is the entire thing, this is all you need to be able to call any API, so long as there is an API that you have access to from the provable service. It is that easy. So if you're making a smart contract today and tomorrow, maybe Sunday morning if you're crazy, and need external data, this is the quickest, easiest, and provable way to do it. Incidentally, why we call provable things, it's because we actually do things provably, which this example isn't showing you. This is just a very simple, basic way to get up and running. But by provable, we mean that we supply with our API calls authenticity proofs, which are cryptographic guarantees to prove that no tampering happened. I just read that off the slide, which I know you can do. We use various different ways to provide these guarantees. But all of them backed by TEEs, which, if you've been to all the other talks today, you're kind of familiar with TEEs now. Who is familiar with TEE? Excellent. A TE is a trusted execution environment, which is some form of like hardware or chip that provides cryptographic encryption of stuff happening. So SGX, Intel SGX is one of them. Amazon and their TLSN Notary provides a cryptographic proof not in the TEs. Android has its own sandboxing, which you can use as a TEE. The ledger, if you're using ledgers and all the various hardware wallets, they are trusted execution environments. And we use all of them to do things and say, hey, look, you asked us to read this, API, and we did it via this trusted execution environment, and provide a proof to do it, that we did it. So you get the result back and a proof, and you can verify that yourself, so you don't have to trust us anymore. We don't want you to trust us. We're very trustworthy, of course, but we don't trust in this space. We verify. And so we provide proofs so that you can verify we have done, or rather the thing you have asked to be done was done. It's not us doing it, it is our execution environments doing it. So I've highlighted it in orange/yellow, whatever colour that is on the screen, to show you how you would use a proof in a query. So here is another complete example. This time we're doing something that everybody wants to know, which is getting the price of Ethereum in, this one's in Bitcoin. I thought it was in USD, but it's not, it's in Bitcoin. But again, this is a common thing. On the Ethereum chain, there's no concept of a US dollar value of Ethereum. It doesn't know what it's worth. But we can find out via an external API call. The key on this one is that we have the two functions, one calling a provable query, again using URL, again using a JSON parser so that we can get the particular value we want out of the URL. Again, we're using the callback, but this time the callback has 3 parameters, the third one being the proof. So we return the ID, which is a hash, which is unique to your ID, which means you can use it to track your IDs in more advanced examples, all of which we have on our GitHub. You've got the string result again, and now we have the bytes, which are the proof. Here we're not actually using the proof, it was just put in here to show you that we do provide the proofs, and the key on this one is that you can see via the constructor is how we actually tell the service which proof type we want. So in this one, we're saying provables are proof, and we want the Android proof, please, which means it's going to use the Android TEE to perform your query, and then it will return to you your result, plus a proof that it was done in that way. And you can take that proof, and you can go and validate it yourself and say, hey, that is correct, it was done this way. And then you can trust us, you just have to trust Android that it goes. So that's cool. Thing happened. I didn't touch it on spec.
What happened?
It was pasting something.
Oh shit.
Was it?
That was like a really big password.
I did it.
I don't really know how it does random shit. Just letting people stuff.
We're in charge. So, here's another example. This one is super important, which is diesel prices. When was the last time you used a diesel price? I don't even have a car, so I've never had a diesel price. But if you did, here's how you would do it using provable. Again, look at that bottom function. It is simply a provable underscore query calling the URL data source and a URL itself, this time, whatever that is, fuel.economy.gov. This time, the parsing wrapper around it, you can see it's an XML parser, so we're parsing like a raw HTML given by the website. So that's a different way you can parse it if your API doesn't return JSON. And the other bit that's important about this example is the constructor and the proof type. This time we're asking for a TLSN notary proof. So this is the Amazon backed one. And more importantly, we're asking for proof storage this time. So what on earth does that mean? What it means, I'm glad you asked, is that the TLSN proof is massive. So it's the same problem I mentioned earlier, where if you just query a URL, you might get a lot of data. And that string won't fit inside the callback, it won't fit inside a block, it's too much data. The TLSN proof is the same, it's a very big cryptographic proof, and it is a variable size. So instead of trying to feed that all to your callback function via the bytes proof that adds to the callback function, we can say, hey, please store it on IPFS community. At which point, when you get your callback, it will provide you the hash of the IPFS hash, of where the proof is stored. So instead of getting a huge string of proof, you get just a hash, which you can use to pull down your proof from IPFS. It's there, bro, and you can validate it that way. So there's a different proof type, which is proof storage. So that's what's cool about that one. This is the last one. So this is how to follow. All the code will be available. Don't worry. This is another key feature of whenever you're doing anything cool on blockchains, and that is randomness. And it's like the first lesson you learn is that there is no such thing as randomness on a deterministic blockchain. It's kind of included in the name. So randomness is difficult, and here is a way you can get randomness that is provably random. See what I did there with the name. So again, we import our API on the top, and this is the random data source we're going to use this time. But the key on this one is we're using a ledger proof. Now the reason we're using a ledger proof is that the random bytes are created on the ledger. So we're using the ledger trusted execution environment in 2 ways. One, thank you for closing the door. One way is to actually use the random number generator on the ledger itself to create the random bytes, and the next is to use the TEE of the ledger to say, hey, I created those bytes, this is the ledger. So this is why for our random data source we use the ledger proof type. And again, this means you have to trust ledger, the people that manufacture the device. You don't have to trust us anymore, because you can verify that, oh yes, a ledger made this randomness and it proved it. So once we've set that up, this is how you get your randomness. So this time we're using what we call it the get provable random bytes function, we're going to ask for 7 bytes delay. That's a new thing. Here's a parameter you can add if you like, and it's a delay, which is to say, provable, give me a query result, but do it later. So if any of you have written smart contracts where you want something to call it after a day, that's kind of hard to do. It can't be called itself and you can't delay anything on change. But if you make a provable query, you can. So in this case, I didn't. I made the delay 0, so I'm not sure why, but there it is. But you can add that, and it's up to 60 days, whatever that is in a Unix, in second. So the delay is in second. And the callback gas is 200k, which is another thing, which is that when you make a provable query, it is the provable service that calls the callback function. And in order to do that, it has to have gas to do it. And of course, we want the contract who makes that call to be the one to pay that gas. So you define how much gas you want to be taken out of your contract at the time of your call in order to power that callback. Now, in this case, we've asked for 200,000, but what you would do in practice is run your callback itself to find out how much gas it costs and then ask for that amount so that you're not wasting it. You can also burden the caller with that gas cost if you want the caller to be the one paying for the query, which is a common use case. So common, in fact, that I wrote an example that's in the Ethereum examples on our GitHub to show you how to burden the caller. But in this case, we are asking for 200,000 callback gas to power our callback. So this time, we're not calling provable underscore query, we're calling provable new random DS query. DS standing for data source. We probably should have just written data source. And passing it our delay, our number of bytes, and our callback gas, and that's it. Here we get our callback, the same format as all the rest, double underscore callback, 3 params, query ID, the string of the result, and the bytes that are the proof. In this case, though, the reason this example is here is because of the ledger proof and because of the way it's set up, we can verify the ledger proof on chain, which means that you can switch in your contract on whether or not your proof was valid or not. So the other proofs and the different ways they work with Amazon and Co, the various different ways you do it, you can validate them off-chain because of the size of the proofs and the way that you have to ask certain services that they did things. That is impossible on-chain. But the ledger proof, because it's both small and the code we wrote, means that you can validate that on-chain, which is great because now, especially with randomness, it means you can trust the randomness in a completely decentralized fashion. You can just rely on the contract to switch on whether or not it passes. So it's a bit of a mouthful, the function, the provable underscore random DS underscore proof verify underscore return code. But all we're doing is calling a function that's in the API, passing it the pieces of data we got back and saying does it equal 0. So if it does, we're saying, hey, our proof passed. Now we can do what we want with our randomness. And the else, of course, is it didn't pass, at which point you would handle that however you like. So I won't go through the last bit of code there, which is about how we're actually turning our bytes into a random number. That's just some maths. You can have a quick look in our repo for that. I think there's a more descriptive version with some annotation for that. But basically all we're saying is, hey, I got some random bytes from a ledger. How do I turn that into a number so I can use it for counting? So that one is the last and probably most advanced example I'm showing you today for how to get randomness. So that just tells you pretty much everything I did about it, except for the bottom bit, which is to say all I've shown you today are the URL data source and the random data sources. But we also have a Wolfram Alpha data source if you want a Wolfram Alpha query. We can do nested queries. Nested queries are cool, which is if you want to say, hey, I want some randomness, but then I want to use that randomness to make a URL query. That would be a nested data source, so you just chain them up. Chain away. Encrypted queries, they're great. What if you're calling a URL that has a password or it has some form of credentials? You don't want those credentials publicly on the blockchain. Well, we have an encrypted query, so you can encrypt it, so it's on the blockchain, but nobody can read it, even better. And then the last one is the real powerhouse, I'll just give you the taster, is the computation data source, which is where you say, hey, make me a query, and that query can be anything you want. And how it works is that we spin up a AWS instance and run a Docker file of your providing, and inside that Docker you can run whatever code you like, so that we can basically query your Docker file, have it run its code, and whatever it returns is what the provable service returns to you, which means you can now do arbitrary computation that fits in a 5-minute window, is the only caveat. on with a smart contract. So you can basically do anything you like now. You're no longer confined to solidity, to block sizes, gas amounts, or anything. So it's super cool. Oh, there was another example, but I don't have time for it, so I'm going to skip it. This is a proof verification tool down here for verifying the other proofs I mentioned, although the ledger and the random data source proof is the one that's the on-chain, so you don't need this tool, but this is here for if you need it for the other ones. And finally, these two little extra tools are ways for you to do the test query tool, especially the top one, will be of use to you if you're using this for this hackathon, because it's a very quick way for you to throw a URL at it and then see what the service will give you back. So you don't have to do it via a smart contract. You can just run that tool and say, hey, what does that give me back? And you'll see exactly what Provable will return to your smart contract. They're super quick for figuring stuff out. Finally, congratulations, you're a Provable expert after that whirlwind tour. But more importantly, get using our API in your hacks. We've got $5,000 worth of API credits for for whomever does it the most awesome, which will be all of you, so it'll be impossible to choose. So there you go. Any questions after that rapid fire talk? Maybe. Go ahead.
So it seems like generally you would have one smart contract per query. It doesn't seem flexible to have multiple.
Why not?
Well, you have the underscore callback
Correct.
function.
When you make a query, I didn't mention this, but when you make a query, when you actually call Provable Query, it returns to you the query ID. So all of those I just called it so it looks super simple, but you can actually get a return from that, which is the query ID. And that query ID is what is the first parameter in the callback, which means you can switch off that query ID. So you can make multiple query types and just store the ID and then do whatever you need depending on the query. Cool. Anyone? Go ahead.
The stuff you run in a Docker container, is that inside of the
Yes, yeah, Amazon, AWS, so you can prove it ran, prove when it ran. It's all provable, funnily enough. But yeah, cool. Go ahead.
Yeah.
Oh, nice t-shirt.
Oh, thanks. Yeah.
It's the enemy. It's not technically great.
Are you able to also use Provable for side chains as well, like where it's used?
Yeah, so we have an integration coming on Loom and others, but basically at the minute, with the Ethereum bridge, which I briefly touched on, if you have anything that is Ethereum and EVM based, it will work out of the box. So it's that simple. And other ones that aren't quite the same as EVM, like the OA system, it's in progress.